Hello everyone. Today we will look at in this video a simple guitar tuner that I wrote. Basically hacked some of the original existing code and wrote some functionality so that it can be converted and used as a guitar tuner. I will walk through the code and discuss the main points, and we'll also see how it actually works. And first of all, the program is available on GitHub. So if you have the Git package, you can basically just copy this and then you can do git and then do that one. That will download the whole directory for you, and then you can cd into that and run the package. And if you want to run this, we need to install two things. One is aubio package, and another thing we need is pyalsaaudio. So we need these two, so we have to install that. So you can use pip. So better is to, if you're already using an environment, you can say python 3 -m. So we can create a environment, temp environment, and then so once it does that, we can actually activate it. You can go to, it is here, right? And then you say temp environment and so bin activate. So now we are here inside that particular environment, right? So now we can install pip install that one. So the pyalsaaudio in the package, it is actually called pyalsaaudio when you import it, but when you install it, there's a py. And then you can also install pip install audio by aubio. Once you do that, and then we can actually run the package. So I'll go to the where my folder is here. So you activated the package, and then here, so we have, these are the files that we have in the folder, and so the main thing that you have to run is python 3 and this is what you're trying to run, my guitar.py. So my guitar.py, and if everything goes well, you'll start seeing the frequencies. So on the command line here, you see, so you have 3 flags. So we have the frequencies on 3 notes and the arrow points where the frequency is. So we'll try it at the end, and on the prompt we have this output as well, and this is a GUI output. If you want to turn on, you can turn off the command, the shell print. So we can quit. So now let me go through this. So basically, remember, so we have 3 nodes, and where in between where the frequency is coming. So let us walk through the code, and let me explain the basic stuff. So the primary thing here is from the aubio website. Let us go there. So if you go to here, this is the audio bio website. So there's a package demo ALSA, So this is a piece of code. So let me maybe I can show you in the. So what I have done is, so this basically import pyalsaaudio and aubio. Let me show you. So vi. So that part is written in underscore. So when you look at, so we have the pyalsaaudio and aubio, and yeah, so the package basically, yeah, so we have pyalsaaudio and aubio, and you also need to install NumPy if you haven't done already. So it basically reads the data from the microphone, and then here it tries to it prints the frequency of that particular. It analyzes the audio, which is it extracts the audio from the microphone and analyzes it and prints the frequency of that of the audio. So what I have done is I have used this piece of code and used those frequencies and modified the code in such a way that we can use that to use those frequencies to analyze the frequency from a guitar and look at the frequency and see if you can use it to somehow tune the guitar. So this is a piece of code. So this is the address here. For this to work, I also need the frequencies of all the notes. So those frequencies I took from there's a table here on this website, and so this table I basically scraped it and made so we need these note labels C0, C1. These are the musical notes and the corresponding frequencies in hertz. So we are basically interested to look where we ideally need when we actually tune, we only need the labels. But to put the label, we need to really know which frequency the sound is coming at, and then we need to put it on a label on top of that. So we need both of these. So that data I collected and it is saved in a pickled file. So we load that. It's a list. This is a format. So it's a list of two lists, basically list of list. So we have one list here, which is the frequencies, and another list, which are the notes, basically strings. So F1 corresponds to note 1, F2 corresponds to note 2. Note 2 is the label. So it's like C, D, F, F sharp, and so on and so forth. So these are the initialization parameters for the aubio and pyalsaaudio, or the sample rate and stuff. So this measurement of frequency, initialization, and now here comes this is part one part we need, because we have when we start the mic and listen to mic, we have lots of things coming through, basically noise. We can suppress it with the pitch set silence, all the parameters, but still you may get. So this I wrote in to reduce the somehow to look for only things that we want, in that way somehow be able to reduce the noise so that the needle is not jumping back and forth all the time. So this is simple. So we have all this list, right? This is the frequency note is a list, and so we collect the 0 means the first list, actual frequency in hertz. So we looked at the frequency is in this range. So we look at the microphone the software collects the frequency in hertz and we match it in where does it come in this range, right? Because this is the only thing we are interested, or around this. So that will give us a tuning like a 10, around 10. Now at the moment it's a minus 10 plus 10, so around 20 hertz. So we look around that, we can fine tune it if you want. And once it finds a match, it actually says okay, it is in the range or not in the range. And now it comes, okay, this is a measurement. So this is that part. So this point, the frequency is measured and we look if it is in the range. And if it is so, we append it to a list here. And then we find the collector series, because the data is keep on coming, a bunch of data is coming. So we keep on looking if it is in range and keep in the list. And we measure whenever we get around list of two elements in that, we take average of that as the frequency. And then this is the part where we have to see to draw the tuner. We need to see that where the frequency lies, right? So let me show you maybe in a. So we have the range, say C, right? C sharp, say D. So we have this range. So suppose this is F1, F2 and F3. Suppose, so we are looking into, suppose our frequency measured is F. We are trying to find where the frequency lies. So we are going to scan through the whole set of frequency, the list. So we have this list of frequencies, right? We have whole frequency from that website. So we look through the frequency range. Now suppose I find, okay, the measured frequency is coming between, say, these two. Now the question is, if you are seeing the pattern is something like this, right? The needle. So we have three frequencies, C, say C sharp, D. So now I am interested to see where the frequency comes. It's here, coming here, here, where. So I need three frequencies. In effect, I have only two frequencies to set up. For the drawing purpose, I put three so that we can draw in as an arc. We can also draw in a single line, you know. So it looks better as a circle, I believe. So if you say the frequency is coming here, and I just say I can take either these three ranges. I can just take randomly take this one or this one as my third one. I definitely pick up these two, and I can pick this or this. The way I did is, I suppose this frequency is coming in between these two. I say that if the frequency is less than 50% of this separation, means here, close to here, means let us take, we have three frequencies, one here, one here. Suppose the frequency is coming here, somewhere here, which is less than, this is the half of this mark is half. If it's less than half, I took the lower frequency. So this will become my lower frequency. This becomes my middle frequency, and this becomes my high frequency. In other case, if the frequency is coming here more than high, I took this as my, so this becomes my lower frequency, the middle becomes my middle frequency, and this becomes my high frequency. So that this is lower frequency, middle frequency, and high frequency. So that is one point. That is what, it's a simple comparison and running through the list and picking up this frequency. So we have two, so these two, if and else, is if it is in the first case or if it's in the second case. So depending upon that, it determines three frequencies: the lower frequency and corresponding to what is a note corresponding to that, the middle frequency, what is a note, and then so it prints in this nice format adjusts the scale and prints it on the command line itself, on the we're printing on the command line or the shell window. And so we'll discuss the other, and so we have two parts, this left side or the right side. So that is mainly that part doing. And now let's go to the graphical user interface. So we measured the frequency, we know where exactly the frequency is now coming. With all that in hand, we look at the second piece of code is in this one. This is what you have to run. Actually, you only run the first one. This file you're running as a Python, and this will take care of the other. So if you look at this, it is importing that file, and it is importing that particular function which measures the frequency. That's what this does. And rest is basically we are using tkinter to draw the GUI, and we are drawing on a canvas. And here so we draw the canvas and the quit button, and using again NumPy. So the main idea is that, so we have a function here called draw tuner. It draws the interface, right? So the point, again, let's going back to here. The point here is that on this display, this is a canvas, right? This is a canvas. So we have a canvas here. This is a canvas, tkinter canvas. And so we have, this is a 0, 0, and this increases in Y, right? This is positive. We need to take care of that. And this is the positive X, and so on and so forth. So, and so we can put a margin so that it is not touching the margin, you know. And so here, the main idea is that this data is coming at, say, suppose we have three frequencies now: lower frequency, a middle frequency, and high frequency, right? And corresponding nodes, C, C sharp, D, whatever you call it, whatever corresponding nodes, the labels. So this D, the high frequency, suppose this is coming at, suppose this is my needle here, it is now 0 at angle 0. And this, if it is needle is here, this is my theta, that will be 90 for middle frequency, and this is 180. So we basically, what we are saying, the one of the important point is the conversion, right? So we have to represent, say, so we have three frequencies. So suppose if I take and 0 and so I take 0 to 90, right? Suppose I have two angles, 0 and any angle, theta 1 and theta 2. I have to map into, say, two frequencies, f1, say f2, has to be mapped into these angles. So we simply, what we say, we'll say the theta will correspond to theta 1 plus theta 2 minus theta 1 divided by f2 minus f1. So this is the whole range. We split it into how much of this is, and f is the measured frequency, f minus f2. So this will give me the mapping. So now for a given frequency which is I measured, I know which angle that corresponds to, and from that angle we can use simple, equations like x equal to r cos theta and y equal to r sine theta. So that we suppose for a given position, say this, so we have suppose this is the angle psi, right? So if I can say this is r, so r cos psi and r sine psi, so I know where exactly to put my point. From that, if I give that x and y, I can convert into the corresponding canvas coordinates and then plot that particular point and then draw a line. So I know the line corresponding to this. I know where this point is. Now I convert into canvas coordinates by simple transformation. Like I know this is 0, 0. I know I can find out that is this, you know, depending on, because I know all these dimensions. So that is one of the basic ideas here for plotting and conversion. So let us go back. So I said there's a draw tuner, right? So we do all those thing. So now if you look at the code, that function, the main thing is, so you draw the function. So here the draw tuner is called with some default values of that position of the needle, where the needle is resting. I mean, it's initial starting. Well, we don't have nothing, no data. We just put some data, which is at the 0th position. So now the function is run one time. It does all these calculations and everything. Now we use this canvas.after method. After 10 milliseconds, we run this function, which is basically again the same. It's calling the same function after 10 seconds. So with xf and yf, the xf and yf is coming from here. So where it has to come? It is coming from this data, which is coming from the queue. So we have a queue. So we are writing on a queue the data from the previous module. So let us so for this module, if you look at the data is coming, it's just putting the data on a queue. And the data, the format is basically it's a tuple of tuple. So it's a lower frequency corresponding string, middle frequency corresponding string, so on like that. So now, so that is read inside a try loop. So we have a queue here. Queue is equal to queue module, and that it is reading the data from the queue module here. And then that data is analyzed, which basically contains all the things we want. We basically need what is the frequency and what is the note, and this converts and the conversion, the thing that I told, the conversion to, so that we can calculate the corresponding angle, then conversion into corresponding coordinates on the canvas takes place. So the queue thing, how that happens, so that is the way it's keep on running. So now somehow that other file needs to be run, right? At the moment we haven't seen that. So we have a producer and a consumer model for threads. So we use the thread module. So we have a thread. From the threading we are importing thread, and there's a queue also. So we have a producer thread, which is nothing but a measure frequency, and we are passing this instance here q, so that it can put the data on that. So measure frequency is the frequency from the previous module that we first saw, which basically extracts the data from the microphone, analyzes it, finds the frequency labels, what is the actual frequency for us, and then we do a thread, right? So we create a thread, new thread with the producer, and create it as a daemon thread, so that when we exit, everything exits, the kids, everything dies. So this is producer. Now the producer is keep on running and keep on putting the data on the queue, and when you run this main file, so what happens is first of all you run this piece of this draw tuner, and it actually calls itself after 10 milliseconds, and then it tries to keep on extracting the data. So every 10 milliseconds it is extracting the data from the queue, and it keeps on plotting for us. It deletes everything previously with this canvas.delete and it will keep on deleting. If there is no data, it puts the last data, so that the needle doesn't keep on moving around. So basically that is the main idea. If you want to, let's say, have a demo. So this is my guitar GUI. That's the way we run it, I believe. Yeah, so now let me see if we can do something, how it behaves, right? So I am lower E note. This guitar is tuned, so that's it for this lesson. And if you would like to modify it, or maybe improve it, reduce the noise, or improve the display, so it's a simple, nice. I really enjoyed doing it, and I hope it was easy to follow. Thank you for watching.